Okay, so today we're gonna establish Mayer's formula. That is nothing but a relation between Cp and Cv. So I know that whatever heat I'm giving, let us say I'm calling it delta Q. Whenever I am giving this heat, that is used partially in increasing the internal energy and partially is doing in the work expansion. So I'm calling it delta U and P delta V according to the first law of the thermodynamics. Now, if I'm saying if this Q is absorbed at a constant volume, if my delta Q is absorbed at a constant volume, so what I can say, CV, it is equal to delta Q by delta T, and I'm talking about a constant volume. That will be delta U upon delta T, sorry, at constant volume and 0. Why? Because change in volume to hai nahi, so delta V is equal to 0. Now, I can write it down as CV is equals to delta U by delta T. Because why I've removed the subscript? Because whatever internal energy of the gas, that depends only on the temperature, not on that volume. So this, let us say it is my equation number 1. Now, I am saying if delta Q is absorbed at a constant pressure. Okay. So what do I call it? I call it Cp. I'm calling it delta Q by delta T at constant pressure, which is delta U by delta T at constant pressure plus P delta V by delta T at constant pressure. Again, I know that the internal energy depends only on the temperature. So can I say Cp is equals to delta U by delta T plus P delta V by delta T at constant pressure. This is my equation number 2. Sorry. If I have 2 minus 1, I have Cp minus Cv, that comes out to be P delta V by delta T at a constant pressure. If I'm talking for 1 mole of gas, I say PV is equals to RT. And if I'm differentiating with respect to time, delta PV by delta T, delta RT by delta T. So what comes out? P delta V by delta T at constant pressure is equal to R. Substituting this value here, I get Cp minus Cv is equal to R.